In this video, we're going to discuss how to troubleshoot a gas burner on a Cremator Burn Miser model. And we're going to use the step-by-step chart that comes with the burner as it's shipped. It's from the manufacturer itself. In the troubleshooting chart, they have a list step-by-step of what to check if different things are not operating correctly. Such as the first one, if motor will not run, we'll go through and check these steps here. So when you check all of these, everything must be in the sense that the unit is supposed to operate. So you need to have your power switch on, and then you need to tell your control to go ahead and operate. As you can hear here, the motor is running, so we're in the operate mode. So right now the motor is running, but we can act, we can act as if the motor is not running, and we will go through and check all these. So, as it says, L2 and L1 verify voltage. So we go through, you can see the terminals are labeled right here in the control box. So you have L1 and L2. And you can see on my voltmeter that we do not have any voltage going through there. We are set for 200 volts AC. This system is wired up for 115 volt. There are also units that run in 230 volt as well. But for this particular model, we will look for 115 volt. And as you saw, there was no voltage to that system. So that indicates that your fuse disconnect, whether your breaker panel or your receptacle, something is not supplying power to the main unit. Again, all this has to be tested as if the unit is told to operate, like it's calling for heat. So I checked the disconnect, everything, and maybe we had a circuit breaker turned off. So I'm going to test it again. Motor is running, so I'll check terminals 1 and 2. As you can see, we are getting 116 volts. So there we do have proper voltage to it. That takes us to the next step and under the motor will not run, and it asks to check for terminals across L2 and 3. And that should be an optional on-off, which we do not have any optional on-off switches on there, but you can check through 2 and 3. And you see we don't have any voltage through it. All right, I'm going to verify whatever switch we have. I will test that back again. Turn everything on. We are getting proper voltage through that as well. Again, if the motor will not run, you've gone through step 1 and 2. Step 3 verifies L2 and 4 to verify you have proper voltage. And that indicates a burner switch or the timer is open. And as I will say, I will actually, as I turn the unit on, when I will shut the main switch off, and again, we check between L2 and L4, and I am not getting any voltage through it. That means the switch may be turned off. So I'll turn the switch on, check L2, L4, there we are getting our proper voltage. The next step to verify if we're getting proper full voltage is L2 and the thermal switch, which is this switch here is the heat sensor switch, on the terminal 1, which would be the black wire. So we would check between L2 and this terminal, and again, it doesn't show that we have anything running, doesn't have any voltage through it. So I will act as if that is the failed switch. We'll replace the switch. Check it again. There, we're getting proper voltage through it. So each of those steps indicates if you're looking for full voltage of 115 volt through the system if the motor will not run. Now that we have checked for proper line voltage, your incoming voltage of 115, 120 volt, we're going to go through and verify all the other switches work properly, whether it be your air proving switch, your interlock switch, what they call that, anything that's more or less with 24 volt. So we'll keep that there. As we go through the next step in here on the troubleshooting chart is if your motor runs continuously but no flame, or the housing is cool. That means the motor is operating, but we're not doing any flame, we're not getting any burn. So we're going to go through the steps here. And as we verify step 2A and B, we have already verified the thermal switch was done in the previous steps, so we know that that's properly working. So we're going to go on to the next steps. So we'll check the 24 volt between terminal strip 6 and 10, and that indicates whether the transformer is operating properly. So with that, again, you need to do this all as if the system is operating, it's supposed to be running. So we'll go through 6 and 10. See, I'm not getting any voltage through there. So that means, the transformer is not sending out the proper voltage. So you need to verify that that operates properly. If you need to, you can change that transformer out. But once you change that out, verify again that it is operating properly. So now the blower is running. And 10. You see, we are getting 25, 26 volts. So now that transformer is operating properly. So we will go to the next step, which is checking the 24 volt between terminals 5 and 10. And that would be the air interlock switch, the motor interlock switch. And that is another thing they call the air proving switch, which is down right here on the side of the control box. And it has a tube that goes into the blower housing. And what it does is it's verifying that the blower is operating properly. It's setting the proper air pressure before the system will operate. So again, you're checking terminals 5 and 10. So you want 5 and 10 where we do not have anything. So it appears that maybe that switch has failed of some sort. The first thing to verify when the system is, again, everything is always supposed to be done when the system is supposed to be operating, supposed to be burning. So if that is, you're getting 0 voltage there, you want to check that aluminum tube that's going to that switch and make sure that there's nothing plugged up in it, any spider webs, any bugs or water in it or anything like that. That'll prevent the air from going and triggering that switch. So you want to clean that out and verify everything's operating properly. Maybe the switch has failed, so if you have to replace the switch, you put the new switch in, you start everything back up. So it's running. Today we're getting 28 volts. We're getting the proper voltage through it. So that has been corrected if that was the issue. So now we're going to test the output of the electronic ignition control and ground. So we want to check 24 volt from the valve terminal and terminal 10. So as you see, there are two terminals for the valve. Hook up to one of those, and 10. We do not have any voltage. So we need to verify what if there's an issue with this. It could be a fuse. There is a fuse on this, so verify that the fuse is working properly. If not, please replace it, and that typically would be the issue if this does not work. So you can see now we pulled the wire, the blue wire, off of the ignition control. So we'll start the system back up. Across the 24 volt terminal in the electronic ignition and the 10. As the ignition system kicked in, you can see we now properly have voltage to it. So replacing the fuse took care of that issue. Now we're going to check if this blue wire coming from the ignition control is faulty or not. So you would check between terminal 7 and 10, and we do not need to verify. Put my meter up there. Between 7 and 10, we're not getting any voltage. Again, it's acting as if maybe this wire is bad, so make sure it's got good connection. Replace the wire. Turn it back on. Ignition just kicked in. So yes, we were getting proper voltage, so replacing that wire took care of that issue. If you go through this, you can see in step 4, and you can go through this and you see step 3 where it says check for ignition spark, where the spark is approximately 1/8 inch long, a gap. You want to verify spark voltages or the actual spark itself through the cables and the igniter. So you can do that as long as you really can't see that much here with the rubber boot on it, but you need to make sure you get proper you can see where it's got the boot on it, so you can't really get much of a gap. You won't be able to see it, but you need to verify that you're getting spark between the wires and ground to verify everything is sparking properly from the electronic control. And again, that is, you want to get an 1/8 of an inch gap between the terminal and the ground. How are you going to verify spark? Normally spark, as long as you hear it, you hear the spark, you can see the spark, it's fine. If you do not, just verify that the wires are good, you have good connections, you have good connections inside there. It's tough to see, but nothing is cracked, nothing is broke. That's the one thing you need to verify, that you have good connections and good wire all the way through. Now that we have checked all the voltages going through the system, we need to verify gas pressure accordingly. So we're going to connect the manometer to the main gas input to verify we have 4 inches of water column. So on the main gas regulator, there should be a test port on the side of it. There may be different valves, but each valve should have a test port. So we're going to connect to this test port with a manometer. You can see I hooked up some fittings to show that we have a manometer connected up. I turned on the gas supply, and in here you can see that the blue outer is listed in inches in the water column. So we do have 10 inches of water column of pressure. You need a minimum of 4 inches of water column. So we do show that we have the proper incoming pressure right now. We're going to show how to verify the igniter gas pressure, and here's your ignition gas regulator right here, and then there's a T block right here, a T, and a fitting on the end. So I will connect a manometer to this point, to that port, to verify that we have between 3 and 4 inches of water column. Ideally it should be set at 3.5. Now you can see I have my manometer connected to the ignition gas pressure test port right here. Again, this is your ignition gas regulator. Again, should be about 3.5 inches of water column. So I have my gas valve turned on or open. Running the system. During the 6-second trial period, it should kick in. You can see we're right about where we should be, about 3.5 inches of water column, so we're good.